Hey, this is Jeremy, and today we're going to be talking about the buffer system aspect of the pH system. So what we have is whenever we're talking about pH, remember that we're going to be talking about the potential for hydrogen, because the more hydrogen you have, the more acidic that you're going to become. Now, what we have is part of the metabolic process is we wind up with H2O and we wind up with CO2. And the CO2 is going to be the waste product that we exhale out. Now what happens though is the CO2 that you have that you retain, for example, if you're not able to breathe off that CO2 for whatever reason, then there's a couple things that can happen then. And to understand that, we have to look at how carbonic acid is actually made. So what we have is we have H2O, and then we also have our CO2. Now, what this means is I have two hydrogen ions for one oxygen molecule for water. And for carbon dioxide, I have one carbon dioxide atom for two oxygen atoms. So if we put these two together, all right, we wind up with H2CO3. And what that means is we are taking two hydrogens from the H2O. So 1, 2. So there's both of those hydrogens, they're gone. They're over here to this other side. And now I have C. I have one C, and that gets used, and that gets brought over here as well. And between these three, this O3 that I have 1, 2, 3. I have three oxygen molecules that are over here on this side that go into creating this carbonic acid. Now, carbonic acid is known as it's a quote unquote, it's a weak acid. And so what this means is it's not very stable, and it can essentially get rid of part of its system if it needs to. And the system that it's going to get rid of is going to be this H2 right here. Okay, so what can happen is you have your carbonic acid. It's going to participate in this buffer system by becoming bicarbonate buffer. And so the way that it does this through getting rid of one of these hydrogen ions, and it becomes HCO3, and it's going to have a negative charge. And the reason for that is because we have this other H, this H plus, it gets thrown away and it gets used in other body systems that your body can use hydrogen for. And so the great thing about this is this hydrogen or this carbonic acid, this bicarbonate buffer, is they are a system. That this is part of your bicarbonate buffer system. And what it means by buffer is a buffer is anything that can absorb or donate hydrogen ions. And the purpose for it is it's going to resist a change in the pH of the body or the system that it's working in. And the system that we're going to be referring to is going to be the body system, so circulating in the blood. So with this being the case, we have our H2CO3. At any time that it gets rid of a hydrogen ion, it can actually become HCO3. And at the same time, all HCO3, which is your bicarbonate buffer, all your bicarbonate buffer has to do is to add a hydrogen ion that is circulating in the body at any time, and then it's going to become H2CO3, which is again that carbonic acid. Okay, and this is an incredibly important concept. It's all part of checks and balances. And so there is this mnemonic that gets taught. It's called ROME, R-O-M-E. And what it stands for is it stands for respiratory, opposite, and metabolic, equal. What this means is that in your pH system, you have two things. So I have my pH especially, and in my CO2, or in my respiratory system, it is predominantly going to be run by your CO2. So in my respiratory system, if my pH increases, then what this means is my CO2 has decreased. Okay, and that's because the higher that you get in your pH scale, the more alkalotic you are. Now, CO2 is an acid, so as my acids increase, my pH scale is going to go down. Okay, and so this is what it means by respiratory opposite. The more carbon dioxide I have, the lower my pH, because again, CO2, that's going to equal an acid. Now this metabolic equal, it's referring to it's going to refer to two different things. And so those things are still going to be the pH. And the other thing is going to be your HCO3, which is your bicarbonate buffer. So what it means by metabolic equal is as my pH were to increase, what's going to happen is my HCO3, my bicarbonate buffer, is also going to increase. As my pH decreases, we're going to notice that my bicarbonate buffer is also going to decrease. And this is because more bicarbonate buffer is getting turned into that H2CO3, which is that carbonic acid. And that is because our body is becoming more acidic at that point. And this is going to be part of the checks and balances and just kind of how your body compensates for the changing pH levels that it has. And remember, a buffer, whenever we're referring to the buffer system, we're referring to the pH system, and we're referring to its ability to donate or absorb hydrogen ions. And this is all about resisting changes in the pH to maintain that homeostasis.